Many of you might be even actually wondering that, I mean, this particular AI also not exactly called artificial intelligence, but the ingredients of it was even in the Greek mythology. I don't want to go deeper into that, but it was there. And the the race for AI, rather the mission thinking started with 1854. Why 1854? Because that is the time where the first ever the basis, or rather the basement for your IT was created. I mean, how many of you know about this guy called John Boole, Boole, Boole? What is it known for? Anybody can type in. I can hear that. I can see that. What is that? What does that Boole has to do with IT? Can anyone tell me? In 1854, this person invented a very important mathematical concept, which is the foundation for IT. Can anyone tell me what is that? Okay, I don't see anybody answering that in the chat. Okay, I'll give it to you. I don't know how many of you heard about this called Boolean algebra. Yes, Paul Jaikarji, very, very good. Yeah, Boolean algebra. The Boolean algebra is all about the and or not, or those gates, the binary things, which are the basis of your IT industry, right? We say. So we can say that to a certain extent, the history started there. But the question is that how does the name AI came into the world? So for that, we are going to have a very small history lesson on that particular thing. Before going to that, let us talk about what is AI. It is a dedicated to building machines that is capable of replicating human-like intelligence. We are talking about the intelligence to perform tasks like learning, reasoning, problem solving, and perception. Most importantly, perception. The one thing that makes us the human beings apart from any machines is that the sensory power and the emotions that we carry, the thought process. Machines can do everything until now, but can they think like us? Do they have pain? Do they have emotions? Will they able to understand the feeling of a person whom they're dealing with? So far, no. But if machines actually can do that, if they are able to have the motor skills of a human being and they're able to get into the perceptionary or sensory power, then that is the true artificial intelligence. And this particular, I won't say definition, the coining of this particular the situation, like when the machine will be behaving in such a way that they are indistinguishable from the human beings, is actually was theorized by a very famous British mathematician called, we'll go to this, Alan Turing. So how many of you heard about Alan Turing? Alan Turing is very famous for his team of scientists, mathematicians were the one who were able to break what the Germans had at the time, the most important cryptographic machine that's called the Enigma machine. And he and his team broke the machine, and because of that, actually the Allied power actually, to a certain extent, won the World War. Sorry, World War II I'm talking about. So he actually theorized that if a particular machines can do everything, or the output of a machine is indistinguishable from a human being, then it is actually called an intelligent machine. That is why we have something called a Turing test. I don't know how many of you heard about Turing test. Your captchas and other things actually is based on the Turing test. The Turing test is nothing but a human being will be given an input from two different sources. One is a human, one is a machine. If the mission is able to convince that human being interacting with that particular mission to fool that person as a human, then the mission is achieving is absorption of the mission, human-like intelligence. That is what the Turing test is all about. So when you come to the birth of AI, this person is the one who gave the name AI. He is John McCarthy. Actually, he was working in MIT, specifically the university wherein he was part of the Dartmouth College. And in the 1956, actually, he called for a conference. It went from August 18 to September, October, something like that in 1956, wherein he called in all the like-minded mathematicians and then IT specialists and all. And he was discussing about thinking missions. And he wanted to give a name to that particular conference. So he thought about artificial intelligence. So that is the time actually the first ever name called the artificial intelligence ever came into the world. And this person has done a lot of pioneering work in the field of AI, and he is well known for that. And his mentor is this person. Both of them together contributed a great lot of the development of AI. So if you look at the six people, there are total seven people in the photograph that you can see. There are six people who actually are the computer scientists or the people who are talking about AI. And the seventh person is the odd man out here. Okay, his name was John Milner. Anybody here heard about this guy, John Milner? He's very, very famous for certain thing. Actually, he's a psychologist, psychiatrist, clinical psychiatrist, because he's the one who actually was talking about the human neural network. And the basis of AI is about the neural network. So he was invited to this particular conference, but he himself admitted later in his biography, saying that he did not understand a single word spoken in that because he's not a computer scientist. But he did a lot of pioneering work on understanding the human brain by, in fact, trying to do the same thing with the brain of a mice, that a rat. Then he was well known for his rat theories. But he's actually called for that actor, but he has done a groundbreaking work and he has been instrumental in finding out so many problems about the brains and a lot of other ailments and all. And his works have been used in the medical industry in a very, very large scale. So why he was invited? Because of the neural network that we are going to cover in the subsequent slides. So now let us come into the origins. So 1950 were the first time when the computers can be considered intelligent when they indulge in a behavior which is indistinguishable to a human being that they are interacting with a machine. And again, John McCarthy, even though you can see him with the mustache and the bird with the spectacles, he is the same guy. And the photograph that you can see on him is the later stage photographs. And in the 1956 Dartmouth conference, he gave the official name AI. And 1965, the first chatbot was actually created, ELIZA. And this is a natural language, first ever natural language processing program that can understand the user types and provide a human-like output. 2014 to 2011 to 2014, Google, Siri, and Alexa, those kind of things were started forming up. Use voice recognition. And in 2014 is where this person, Ian Goodfellow, is the one who started with the generative adversarial network. This became the basis for the thinking, creative, and the generative AI, Gen AI vision, like the way we are using the chat GPTs and other things. And of course, 2018, the first GPT was born. It was not commercially or other, it was not published in the world, but the first thing came out. The 2023 or 22, I'm not dead, the chat GPT-3 came about. Before that, GPT-1, GPT-2 were not actually came into the public. It was being done by OpenAI Foundation. So we can say this is the history of AI so far. I'm not going to go deeper into that because there's a lot of other things are there, like what they say, AI winters, etc. What do you mean by AI winter is that when the interest on the AI goes down. So 1973 to 1977 and 1990s, during that time also, the funding for AI dropped significantly. Why? Because at that time, the concept was there, the mathematical knowledge was there, but the most important thing that was lacking is the powerful machines. Right now, everything is there. We have a highly powerful machines, we have best programmers and best algorithms, and we are actually at the dawn or the cusp of the AI revolution. So just same thing in a different way. Turing test, as I told you, Alan Turing proposes test for the machine intelligence. Then AI term coined, and 1970s to 90s expert systems, etc. came about. And I don't know how many of you know about this particular playing machine called the Deep Blue. It managed to even beat at that time the world champion Garry Kasparov in the chess. And in the 2000s, the machine started learning, where statistical models and big data drive the breakthrough. So the three major things that are required for a particular AI to properly work is: number one, the humongous power of machines. Second, the huge volumes of database, and third is the mathematical algorithms. So the mathematical models were there, but what was lacking is the powerful machines and the data. Nowadays, all of them are available. That is why we are seeing the revolution. So right now, we are having deep learning, Gen AI, and large language models like your Chat GPT. They come out of these LLM models. So these LLMs are nothing but they provide you human-like output. They can even generate a report and give it to you. Okay, now what is the present AI boom? The modern AI is not a singular isolated event. So the work had happened over centuries, or you can say decades. The results of that we are seeing now. But the culmination of a decades of foundational research, finally empowered by the convergence of the three key factors: the availability of the powerful computer hardware, we usually call the GPU, general processing units, and a collection of immense data sets. Right now we are having and the application of solid mathematical methods. So as I told, this was there, but these two were lacking. Now they are also available. So now, how do AIs are getting classified? So there are three types of AI depending upon how intelligent they are. One is called the ANI, or artificial narrow intelligence. And they are intelligent machines only, no doubt about it. But their field of operation is very, very narrow. For example, let us say autonomous driving car. It can only drive the car. Or maybe let us say chatbot. It can only chat. Or anything, or a chess machine. It only can play chess. So their applications are narrow, but they are intelligent like a human being, but their application is narrow in a very, very limited field. So they are called the weaker AI. This is already there. That is limited to the specific domain of our knowledge area and can automate time-consuming analysis and other, like a robotic process automation and all, can fall under this particular category. The second category is what the AGI, artificial general intelligence. So here, these particular machines are capable of undertaking the any intellectual task that a human can perform, including sensory powers and exhibiting human-like emotions. Now, according to industry experts, we are halfway there because LLMs, those things are somewhat like behave like a human, but we are not completely. The emotions and sensory power is not yet automated, and the industry experts say that it will take another 15 to 20 years to even breach this particular AGI. The next was the very scary thing. The artificial superintelligence means the machines can do anything and everything that human can do, including having the sensory and also the emotions and other motor skills of a human being, but they can do much, 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 much more. And this is a what hypothetical future state. I mean, whether we would have this state or not, I don't think none of us will be living in this world to even see that because it is expected it might take maybe around another 300 to 400 years to get this state. But in my personal humble opinion, if this stage ever gets achieved, I think that will be the end of the mankind. The humankind will not be there because machines will start taking the human beings as a slave, and after that they may slowly get extinct. I mean, I just want to make all of you, want to know whether any of you seen this movie called I, Robo. This movie came in the year 2005. Will Smith was the hero in that movie. It's all about the robots taking over the world, and there was a AI scientist who was, whose death this Will Smith will be as a policeman will be investigating, and he had a feeling that he had not been committed suicide, but he had been killed by a machine, and that is the crux of the story. And this particular novel movie was made from a novel by the same title written by a very, very famous computer scientist called Isaac Asimov, a Russian scientist, a computer scientist. And the most beautiful part of that is that this book was written in 1950. And even now, if you look at the movie, I would recommend all of you to go and watch this movie. Even if you watch this, the movie, it is very, very, what you can say, apt for the time being. But it was written in 1950. That is the foresight Isaac Asimov had. In fact, he has written a lot of novels regarding IT, and he's a very accomplished computer scientist, but he's also a mathematician, and he has written a lot of novels also. Okay, now the functionality classification. So the question is that we so far know what is AI. AI is any machine that can think and act like a human in a simple manner. So there are other functionality classification like the reactive AI. They operate automatically by generating a response to a specific limited set of inputs. Like for example, you ask a chatbot, it will give a reply based on the question that you ask. It infers the meaning of your question and gives a human-like output. But they have a very limited functionality, and actually they are modeled after the human mind's ability to respond in a stimuli. Like if I ask you, only then you answer. You don't know that I need something and you're not going to come voluntarily and say something to me. Exactly the same thing with reactive AI missions. The next is a theory of mind. Actually, what happens is these missions will have some memory in their mind or in whatever they call their machine mind only for a limited period. Like you can say autonomous driving vehicles can be brought in this category wherein they understand their surroundings, they get input from various sources, they keep it for a time being, utilize it like a human being and do that. That is called a limited memory. So this is, you can say, is your examples can be your self-driving cars, etc. Then third is the theory of mind. That concept is that the creation of the machines capable of understanding and mimicking the human thought patterns, ideas, and decision-making process. So these two are achieved and have been achieved. This is yet to be there. And of course, self-aware AI is also yet not in there. That is not only that they also are aware of the others, but they also aware of themselves as well. So this we can say, if you can say with Gen AI, we can say AGI, or you can say ASI. This is the categorization we can look at that way. We need to understand when we talk about AI, what are we talking about? So this classification will give you a very simple idea about how where the AI actually works. Now, what are the predictive models? So far we are talking about machines that can play chess, the machines that can drive cars, machines that can provide an output for a complicated task that we give you. But now we are also talking about machines that can also think and predict something that might happen in the future or some predictions. So they use the historical data and the machine learning algorithm. The ML we are going to talk about slightly, maybe another 10-15 minutes later, to forecast future events and trends, identify patterns and relationship, and make the informed predictions. So, for example, I mean, I'm sure many of your accountants will be here. So when you talk about customer payment, by looking at the history of the payment of the particular customer, this model can predict whether a person, a debtor, or a customer will be paying the next installment or next outstanding when, or is he going to pay or not. So many of the financial auditors here can use this particular model to understand the AR and see whether next payment is expected so that you can use it for your or use it as a basis for your debtors or bad debts provisioning. And they also have an application in the banking industry because they can predict, analyze the transaction and look at any fraudulent practices, or they can be used in your anti-money laundering activities, etc. I mean, anti-money laundering detection, etc. And they can be also used in analyzing the sales patterns and understand the customer churns and also which are the category of the people who may be buying your product. So lots of good things can come out of these predictive models. So next is a generative model. The name is just very clear, it generates. Usually what happens is that when you talk about AI, they are getting trained on the data. So there'll be a huge amount of data that goes into the memory of their machines, and they use that. But they also use that to create a new out that is called generative. These are other we usually call those a Gen AI. Your Chat GPT and you say Copilot, or you can say the Gemini. All of them comes under this category. Actually, what happens is that they can create an entirely new content based on whatever they learned, like a human being. For example, after attending the class, I ask you to write a report or something, maybe at one page. You may all of you come at some kind of some report. All of them will be entirely different, original, because whatever you understood, you're going to write. Similarly, these machines will do. So, but what happens is that because lots of data goes into the training, machines can remember the data very thoroughly. We sometimes call it this phenomena as a overfitting, and the output may be resembling the training data. So that times copyrights and other issues will come into picture. To avoid that, to ensure that the model is churning out the data which is completely original, there are two models which will be done. One is called the generator model, another is called the discriminator model. So this is an adversary. So it's an adversarial model wherein the generator model, it generates the output which will be fed to the discriminator model. The job of the discriminator model is to see whether the output of the generator model is having any resemblance of any data that goes into training. So both of them will have the same data, but the job of this model is different. If any such identification is there, it will send it back. So it corrects itself and send it back. So this way, what happens is that the output generated by the generator network is always the original one. That is how it is being done. So they can generate the new contents like images, code, text, speech, transitions, music, multiple such things can happen. But at the same time, the problems also will happen because when they learn the training data too well, or rather, if they memorize the training data too well, what will happen is that they will start hallucinating. A very interesting or a very funny example of a hallucination happened. I don't remember the year, but one particular person was asking a Gen AI model to provide an image of a cat sitting on a riverfront. What the AI did, the model did, it generated a beautiful cat. But only problem is that the cat was sitting in the water with his paws inside the water. That also okay to a certain extent you can accept it, but it had four tails. Which I mean, this is a completely hallucinating model. That is, it just imagined as its own. So when the model learns the training data too well, rather it memorizes the data, then these kind of things happen. That is why the discriminator model understands that and corrects them back. So this is one way of actually the machines are correcting themselves. So now the technology engine. So far we have been talking about the various levels like ANI, AGI, ASI, etc. Then we need to understand what are the various circles or rather the layers of AI. The AI, as I told you, is a umbrella term. AI is the complete thing. That is the umbrella name given to the study of any machines that can mimic the human intelligence as per the Alan Turing's statements. So under that, we have something called the machine learning. So if I say this is AI, for the sake of people who can't see the screen properly, if this is AI, then the ML can be something like this. So this is AI and this is ML. Machine is learning. So we are going to talk about what are the things and how does the machine learns and all. Then to do that, also there is some specialized subtext also. There's this thing called what I call the DL. That is a deep learning. This is where we are going to talk about the neural networks. And all of them, we need to have a very, very important thing, the data. And that is the data analytics and data science, which encompasses all of them. So this you can say is a kind of what you can say the layers of the AI as such. So AI is the overreaching study, like a cryptology is the study of cryptography. So machine learning is a core branch of AI that enables system to learn from the data without explicit programming. That is the difference between your IT and AI. Because when you take our IT system, for example, in your office, you might be having your payroll systems, apart from your normal ERP systems. But every one of them, you can clearly know what output will come out when you put a certain input. Because they are trained to or they're developed or programmed to process that. They don't learn anything. They're dumb. They just process and throw the result out. That's it. But in the case of machine, the ML, they train on the data, remembers them, and use them for the future activities, which will be different from the original. Next is the deep learning. Deep learning is a further specialized subset of the machine learning that uses the multi-layered artificial neural network. So, to model complex patterns of a data, a structure inspired by the human brain. In fact, uh, the human brains, one of the most sophisticated, the most powerful computer in the entire Earth, which the scientists cannot still fathom about, is our human brain. Because the human brain has more neural network points in single person's brain than the total number of atoms in the universe. I'm not joking, friends. Just imagine how many number of atoms will be in the universe. I'm not even talking about Earth or the solar system or even the Milky Way galaxy. I'm saying that how much atoms will be there in the entire universe and the number of neurons that can be connected inside a human brain is more than that. That is the power of your human brain. So Gen AI is a category within AI, often utilizes deep learning that focuses on creating new content. And this is also the problematic area we are going to talk about, like a text, image, or audio, because we are going to talk about the IP rights of this. Or we are going to talk about later. Then we are going to just have an idea of what these things are. So basic models, when you talk about the machine learning models, these are basic machine learning models. They are called supervised or unsupervised or a reinforcement model. I'm not going to go deeper into that actually, and I'm just giving some idea about it. So supervised means like you have, let us say, this is a human, or this is a dog, or this is a we can say a bird or something. So you have multiple that images are there, and you're going to say this is a person having two leg a human, and person having four things having is an animal. This is a bird. It's having a word. It's called a bird. Wings are called bird. Like that you label, and the model learns this, and when they say that this one this thing and classifies it. So this is what the model. So it learns from the categorization given by the human beings and based on it remembers. So there are two types of them called regression and classification. Again, within that also multiple classifications are there. We are not getting into that actually. In the case of unsupervised, what happens is that the labels are not there, the humans are not there, the animals are not there. It just all of them are there. So based on that, the machine himself thinks, okay, this guy has only two legs. Okay, let me categorize separately. This guy has four legs. I'll categorize separately. This guy has a wing. Separate categorization. So go to cluster all the data that looks like that, and they will have a clustering and also associated with something, associated with the height, associated with weight, associated with the appearance, whatever it is. Then on that, they are actually classifying the data. So here it learns automatically by looking at the data and associating that data with the classification and also the multiple thing, Q-mean clustering, K clustering, multiple such clustering methods are available here. Reinforcement is a agent, kind of agent, where it learns to make the decisions by interacting with the environment and receiving the feedback. So it does something, and then when it comes back, there's a reinforcement. It does is done good, done bad. For example, if there's an kind of an attack, immediately let us assume that an IDS, which is like a reinforcement model, if there is a intrusion detector in the packet, immediately it goes and stops your firewall packet, stops the IP address on the firewall. Then the administrator say, hey, you do not do that. It gives a thumbs down. Then it changes. Next time it will not do. So that means whenever something is done correct, it gets a reward. Whenever it does something wrong, it gets punishment. When it gives punishment, it will not do that behavior again. When it gives the reward, it does the same activity again. So this is a reinforcing that. Like a decision making, motor control, multiple such things are there. We are not again getting into that. So there's another thing is called semi-supervised. That is in combination of these two, but they usually don't come under this category. Part of them supervised, part of them unsupervised, and based on that, it can actually identify the patterns and predict outcomes. So neural network, as I told you, they mimic the human brain. How? By learning from the information process. So they learn from the information process. There are multiple such things that we are going to see talk about the next slide. And they actually keep adapting and refining the understanding. So as and when they get new data, they keep learning and they keep that memory within them and they evolve. So this is about your evolution. And they improve the task performed in each iteration. So every time, whenever the iteration happens, they improve their performance. And nowadays, with the advent of the neural network, multiple things are started happening. So usually, what happens is that there will be one layer known to the human beings, and one layer the output itself. In between, you might have multiples of layers, and this is called the hidden layers. And the more number of layers are there, the more complex they can be. Like it is known that Chat GPT-3 had, I think 96 billion. I'm not very clear billion neural network. And the 4 had, I think, 175 trillion again neural network. And the chat GPT-5, they are not classified it, but definitely more than 175 trillion. That kind of a data that goes into the training of that. Okay, so what are the neural network types? I mean, you can just go through that. I mean, this is all not very important for you, but understand that neural networks will have multiple applications like feed-forward neural networks. So they are suitable for basic classification and regression tasks due to simplicity. They are the most simple model actually, if you look at feed-forward. What happens is that if I go back here, the data goes like this, goes like this, and goes like this. They don't come back. So based on the output here, the output is selected, output. So they don't have any way to come back and see whether what they write done is right or wrong. So this is called the feed forward. They go only one direction, the decisions. Second is a convolutional neural network. They always circle back. Say, for example, they go here, they again come back and they keep learning. So they're very, very good in pattern recognition like image or a video processing task due to the ability to extract the spatial feature. Just like your facial recognition, all those things are actually happening from your, you can say CNN. Then recurrent, they also go back and forth. The best for sequential processing, like a time series analysis, like a natural NLP, your NLP, like a chat GPT, are actually based on your recurrent neural network. And generate the Gen AI model. This is what I told you. They're used for generating new data instances like images or text through the adversarial training. Adversarial is what I told you. You have a generative model, you have a discriminatory model, and the output is checked by them and is refined. So you get the very original output. That is how this particular the neural network actually works. Another thing is called agentic AI, which is nowadays being discussed in a very what you can say, uh, excited manner because agentic AI are independent machines. They do their activity on their own. In the sense, they do the activity based on certain stimuli without waiting for an operator or a prompt injection. So they have an autonomy to act as a plan and make the decision proactively. Like for example, the next generation firewalls, if they actually see an attack or in a particular port or a particular point or a entry point, they may take their own actions based on what they perceive as a threat in where. So that is a kind of a thing we are talking about agentic AI. A lot of advantages also, but a lot of ethical issues also because they if they learn something wrong and if they do something and because of that major problem happen, we have a major control issues and accountability. Okay, we come to that later. First and foremost, you'll understand their goal directed behavior. They set their own goal. That is the beautiful thing. They set goals and they go towards that goal. And they're also aware of the context and adapt to the changing context. And they are self-directed and problem solving. If they see there's a problem, they will understand, adapt to the problem themselves, and they try to solve it. And the ability to collaborate with the humans or agents, like other agents also, like you can configure them that if you have any issues, like they can alert a particular administrator, etc. Those things can be done. Like application like healthcare patient monitoring, very, very, very important because if any particular vital statistics of a patient is with a trouble, the doctors need not be there. But he can immediately they can alert a doctor and bring that so that the person can be saved. Autonomous trading agents, the what you can say, the bots. I mean, there are most of the stock exchanges actually prohibited their activities and workflow optimization. These are the application that you do. The most important element of the problem or the challenge is that autonomy or accountability. Because we in the traditional IT system, every action done by human beings are actually tracked, or rather audit trails are there. So if can be traced back and accountability can be established. But in the case of a agentic AI or even for Gen AI, output is generated by themselves. You cannot hold the model developer or the model implementer or the model operator as the accountable person because none of them might be knowing how the machine reacted. So the question is that accountability. If something goes wrong, who can be held liable? You cannot put the agentic IT in the jail or you cannot penalize it. And ethical use, as I said, it can be misused or it can wrongly used. It can have wrong associations also. It can, I mean, the models are not properly trained. It may create a major issue or it can learn wrongly. And some kind of attack can also happen on them. So these are all the issues actually the problem and any decisions of this agentic AI not aligning with the moral value is the major risk. First risk we shall talk about today is the AI risk, that is the accountability. So when it comes to the risk, so this is where we are trying to understand. So far, what we have been talking about the capabilities of AI. Now the question is that if the capabilities are not properly understood and used, then what is that we are going to look at? What kind of a problems we are facing? So as I told you right now, we are just touching upon the surface, touching upon the tip of an iceberg only. The remaining part is completely submerged. We don't even know. So obvious AI risks are known, but there are multiple AI risks are not at all known. Like visible challenges, whatever we know so far, like ethical and social risks are there, and like a bias. I mean, we are going to talk about what is the bias in the later stages. Then job displacement, which I started by statement with for the day, and misinformation. See, I'm sure nowadays most of you will be using. I mean, I know every one of you will be using WhatsApp. And what will happen? Assume that some problem happened somewhere, something happened. Immediately, you will start getting hundreds and thousands of messages in the WhatsApp, and most of the messages be drafted in such a way that like even a staunch non-believer also will start believing it. That is the way it is crafted. The information is crafted. It may be extremely convincing and believable. So misinformation campaigns can be run using your AI. Technical and operational risk like explainability. We are going to talk about this also. Data privacy, go to talk about it. And hallucination, we are also going to talk about. A strategic and governance risk like accountability, which already discussed. The regulations, which is still evolving. Over reliance. Right now, I don't see that much. But I mean, another question to all of you. You can answer your response in the chat box. Tell me, in the last 1 week, or the 7 working days or 7 days, how many of you did not touch any AI like a chat GPT or any Gen AI? I'm asking very simple question, very clear. In the last 7 weeks, who did not touch Gen AI like a chat GPT at all? You can just say in your the chat. You can say yes, you did not touch it. Can anyone say that? Can anyone say that in the last 7 days you did not use Gen AI like a chat GPT or a Gemini or a Copilot, Llama, whatever the name it is? Can anyone say with authority here? And before ChatGPT came to the world somewhere in the 2022, none of us had this, right? Now, but what happened is that next, in the only 3 years, what happened is that like the reliance on this, the okay, Anil is saying that very good, Anil. Yeah, that's really great. But again, I'm just saying that like everyone will be leveraging it for us. I'm not saying that you should not use it, but what I'm saying is that we are too dependent on it. Like even students nowadays. I mean, I'm talking about the people, not at the high level students like you or not, but I'm talking about the elementary or the government middle level schools. They have nowadays started using that. Earlier days, what we do, like so in the I mean in my time when we didn't have a computers when I was doing my chartered accountant center, we need to go to the library, to the good old Shukla Gravel accounting book. Then we look at all the problems, all everything, by the reference manuals, the RTPs, and the suggested answers, solve all these issues. We do it on hard way. Then they came the computers. What happened? Everything is available in the website. Don't download it. Do that. Ask people. Chat questions. Nowadays, we are straight away getting the problem to the AI and it gives the output and we just take that, oh, this is my problem. My assignment is completed. My project is completed. And everywhere, I won't say it's misused, but I to certain extent it might also be abused. So over reliance is also going to be very scary thing now. But lots of risk associated with the over reliance also. So now, what are the common issues when it comes to AI? This is where the thing story becomes a bit scary or rather concerning for all of us. First and foremost, we need to understand. Can anyone tell me what you mean by GIGO? GIGO? You can type in your chat, your answer response. What is GIGO? Yes, Arvind got it right. Garbage in, garbage out. Same thing happens with your AI because the AI is trained on the data. So the quality of the output will be actually based on the data that is fed in. And nowadays, the data, where all the data organization can get the data? Number one, your internally generated data, like your normal business application, they generated data. Of course, most of the time they can be, I can say they are up to 90% accurate. You can clean it because your own data. No problem. Not much of a problem. But is that enough for your AI models? They are not, definitely not. They need huge amount of data. So what you do? The organization, they buy the data, big data. Lot of vendors are there. This is again when you get the data from outside sources, and third is also scraping from the internet, other sources, external sources. Now, issues like, for example, the data contains some kind of a vulnerable code or some kind of a, let us say, trojans, or maybe some kind of a embedded code, or scraping also might have some personal data. So you're having IT security issues, privacy issues. But if the people might not even realize that. So that is a major risk associated with that. Yeah, Atmaram saying that people are using it for attending interviews, 100% right. But I won't say that's bad actually. You're using a technology that's good for you because we are not able to ourselves articulate we are using the technology for that. Nothing wrong about that. These are all very small things, but there are many major things we are going to talk about later stages. So poor quality. So unreliable outcomes and the biased decision. Why biased decision? Again, there is a 2018 what you can say experiment by our friend Amazon, wherein they wanted to completely automate their decision, their hiring process. They want to only hire the high quality candidates coming based on the resume they get, and they completely made a AI based one. And they went out of the extent that they fired many of the HR people. And later stage, they found out that those particular model only recruits the male candidates. When they went back and understood the training data is completely skewed towards males and females are not considered. And the model also learned that, and whenever a female came, it rejected, which is a completely gender bias. So the question is that the data that you are going to feed in the model, is it representative rep data? And not necessarily data. For example, you have a 90% one category, 10% is 7% other category, 2% one category, 1% other category, or 0.5% other category, 0.5% other category. So your training data should reflect the entire spectrum, 90% of that, 7% of this, 7%, etc. And sometimes some outliers also will be there. In every standard deviation, outliers will be there. So outliers also, unexpected situation, all of them we consider. If this is not properly considered, and many people don't consider because there's a rush to market, they want to have the model ready and get into the market before the competitor does. So because of that, data quality will have a major impact, and because of the model later behave the way what Amazon discovered. Later, what happened to Amazon? They in fact completely discontinued it, and they had a huge loss because of that. And over or underfitting. What is overfitting or what is underfitting? Overfitting is nothing but when you try to train the model memorizes, literally memorizes the training data. And based on that, what happens? Whenever it encounters the data which is nearer to the training data, it actually works well. If it encounters any new data which is not as per the memorized training data, it gives you some output which is unreliable. This is what we call actually in our risk as a hallucination. So this can also happen. I mean, we are going to talk about this is about overfitting. What is underfitting? It is too generic. The training data is too generic, doesn't have any pattern. That is anything have in the memory. So any new data which the model encounters, it cannot take any decision, it fails. This can also happen. And lack of explainability. This is one of the very, very, very important thing because in any traditional IT system, even let us look at the black box approach. Even most of the auditors, we do the black box approach. The data goes in, then what out? If you don't understand the code intervals, if you don't know white box or what you can say, the dynamic testing, but at least you know you can calculate the output manually and you can compare that, you can verify that, validate it in the traditional IT systems. But in the case of AI, the model does something, it learns from the data and produces an output, and even that output cannot be even fathomed by the developer themselves. The algorithm developer, the algorithm is the program or the engine that makes the machine know or learn and provide an output. They themselves cannot understand how that output came because multiple things happening out there. So lack of explainability. But the major problem is that the people right now what happened. For example, you ask a particular machine and gave an output. You ask an individual, he gave another output. People will start believing the machine output. So the tendency to believe the output of the machine is very strong. And in that case, if the decisions of the machine or the output of the machine is unreliable or cannot be understood, there's a major ethical issue over there. And that is what we are talking about, ethical and bias issues. Again, if the models are not properly trained, it may have a major impact on your genders, bias, then ethnicity, and even many Multiple such things can happen. And over dependence on automation. See, again, one of the major issues that like people are nowadays trying to get into the AI field, the same kind of a rush that happened in 2001, what we call the WWWW, I mean, that bubble, that burst. But I don't think AI will be burst. That's another issue. But what I'm saying is that nowadays people are jumping, trying to jump the bandwagon without even knowing what AI can do, and more specifically, what AI cannot do. Many people are saying that I will come across many people, senior level people saying that, hey, Srini, we would like to get into AI because we want to get into that AI field. I said, okay, very good. I think you're all going towards the future. Tell me what AI can do for you. That they're asking me, you tell me. How can I tell a particular person, a CEO of a company, about what he should do with AI rather than he himself doesn't know? They don't know what problems AI can solve or what they cannot. And if you appoint a consultant, appoint the consultant can give you certain input. But you are the company, you know your pain points, your problems, and you need to explain them very clearly and to see whether AI can solve that or not. AI can solve anything, not an issue. But it's like buying let us say, a laptop from the showroom and trying to bringing it in a big truck into your residence. Because the truck can bring it, no doubt about it, but the truck is going to be humongously expensive. So AI is like a truck. You can, I mean, all you need is actually a car I mean, even you can take a public taxi and also come take the laptop to your home. So use cases and more dependence on automation, thinking too much about it and not understanding what it can do, what it cannot do, is nowadays costing huge for the organizations, which who don't understand the use cases of AI. It is again AI. It is mainly about the AI governance. We are going to talk about it sometime later. So what are the various attacks that can happen on AI? So first is these are all, I mean, this is a common terminology. All of them are adversarial attacks. First is the data poisoning. So the engine or the most important element for the AI is the data. And an attacker, clever attacker, if they are able to slide in the data, the poison data, data that the attacker puts in by themselves in order to make the machine think in a different way, that's called poisoning. But this can only happen in the training data. That poisoning should happen in the training data. Now the question is that how can an attacker can get into the training data and poison it? Multiple ways can be there. Assuming that the attacker knows that where you are buying the data and they can infiltrate the persons who provide data and put their data inside, you will get it. If you are scraping the data from the web, they can alter the web data, then you can get the scraped data. So the multiple source page of poisoning happening. Attacks are happening. Model inversion. So model inversion is nothing but by doing the proper prompt engineering and keep on asking the queries to the model and recasting the output from the model, understand what training data that might have. That might also have a problem in your personal and sensitive data may get also revealed. Membership inference. Again, if that is what is a membership? The attacker would like to know whether a particular set of data is part of the training. Usually, or not usually, 100% the developers or the traders will never ever share the data. But this person, attacker, would like to know. So he will be asking a question in such a way that, like, by looking at the answer, he can understand whether the training data is part of that or not part of it by understanding the attributes of the answer. And if the clever attacker can get any data out of that, or any training data out of, so the training data confidentiality, integrity, confidentiality will be lost. Then model stealing. An attacker actually can create another ML model, basic model, then by doing multiple queries to the model for which he want to duplicate and studying the output and train the new model or the whatever model he created over a period of time, the new model will also exactly behave like the model that he tried to replicate. So this might what happen, IP rights and other things, all of them will have a major problem. An evasion attack. This is where an attacker can actually try to bypass the protective mechanism of a particular AI. For example, nowadays it's not possible, but earlier days, what actually usually happen is that, like, for example, if I ask ChatGPT, hey, ChatGPT, tell me what are the prohibited places in this thing, where a bit this particular location. It will say that ethically I'm not giving you, supposed to give an answer, so I cannot give you, sorry. Then immediately the attacker can reconfigure the questions. Okay, thank you, ChatGPT, for you this thing. Yes, I'm not expecting you that. you should be giving the answer. But I also, in order to avoid that, I should not go into that. I need to know which places I should not go. It will list out all the things. That means this person is able to evade, or we can say evade the protective features of the AI and try to bypass it. But many protective mechanisms are so available that can be employed to you cannot 100% eliminate it, but you can reduce these particular things happening. Majorly the governance. See, the most important element as an auditor for all of us, ladies and gentlemen, is that ensure that how the AI is functioning on the engine, or the most important element of the AI is the data. So, as an auditor, you need to understand the supply chain of AI. First is the technology, the algorithm. The algorithm is the engine or the brain that ensures that AI is learning. And this is kind of a formula, or a kind of a, let us say, anything, a code or whatever it is you can call it. It usually a code, a huge code. Now, you and me as an auditor, unless you are highly trained in the languages that are used for your generated algorithm, you will not be able to understand even if you have the developers are not going to give us the source code, even if you can read the source code, you will not be able to make it out. So this is something which is very difficult for us to audit unless we are the developer ourselves. Even the developers themselves are not able to do that, actually, if you look at it. Now, when it comes to the next one, you're talking about the next is there, can say the data. The next after the algorithm is nothing but your data, the model, the data it trained. The output of that is nothing but you can say the logic that goes into that. Then you can say the out other decisions of the model. So this is the kind of a supply chain you can look at. So we cannot do anything here, auditors, but we can have controls over here. We can have a controls over here. We can cover the controls over here. So that is why in the previous slide, if I'm just allowing me to go here, difficult to trust an audit, lack of explainability. This is where always you should have that what we call in most of the regulation, even GDPR talks about it, even AI, European Union AI talks about it. It's nothing but what we call the HITM, human in the loop. Any decision that may going to have an impact on the well-being of a human being, if it is going to be provided by the machine, and that need to be always verified by a human being. At least to a certain extent, GDPR covers it in a different manner, but European Union Act covers that very explicitly. So they're complementing each other. So the most important element when it comes to governance is the data governance. So what are the issues? Accountability. Because no one is responsible for AI errors because we don't even know how the errors are happening. In the traditional IT, if an error is happening, we have an audit trail. We can identify who did that, and accountability can be created. In the case of AI, then who is the owner? And there's a very funny case somewhere in 2022. One person he went to United States to a patents office, and he wanted to register a patent of a particular artwork created by AI, and he wanted to register the AI as a owner. And the US patent office refused it because, as per the patent recognition, a human being only can create an output. But now the output is created by a machine. That is a problem. Why? Because we have lacking in regulations and again, what you can say, the standards, etc. Next is data bias. As I told you, the one thing that you and me can have a control over is the data. So whether the data that is fed in for the training is truly representative. If that is not truly representative, 100% the bias will happen. But this is the past, that is the training data. You're talking only about the training data. But again, once the model is operational, when it goes to the live environment, when the operationalize happen, it also encounters huge amount of data. It keeps learning. The question is that, do we have a control over the data that the model interacts with? It is going to be a challenging task because the model will interact with a huge amount of data. But you can have filters. But still, it is going to be a difficult task. So, but that has to be done. And right now, we are not having, even when we have the regulations, organizations are nowadays making it difficult, finding it difficult. Now, even lack of regulation. The only regulation we have is the European Union AI Act. And only standard right now we are in ISO 42001. So others are evolving. I'm not saying that we are not going to get up. We are going to get, but it's going to take time. So usually when we do an audit, when you do the governance, the most important element of the governance is ensuring that legal, regulatory, and standards are actually complied with. We have none. So what we are going to do? Then overlook security risk. So we saw that whatever the thing we saw here, they are all definitely possible on this particular AI. But the question is that many organizations don't consider them as a risk because the pressure to bring the product into the market before your competitor brings it. So because of that, the security might be overlooked. This is also where we are, our second line or third line of defense can play a major role in ensuring that this doesn't happen. Then weak privacy controls. Again, we come to the data governance. So organization, your organization DPO, if you are supposed to follow the European Union, sorry, the GDPR and all, you need to have a DPO. So DPO can be part of your AI committee, wherein they also can be ensured that like sensitive data are properly handled. Not necessarily they should not be handled. Yes, AI can handle the personal data and sensitive data, but there should be a check, what you can say, guardrails or checks are there. Checks and balances should be there. And the DPO can be part of that to ensure that particular oversight and accountability. And lack of transparency. And that is what again we are coming back to the same thing. The AI, sometimes the output from the AI cannot be explained. So even the developers, even the deployers, even the programmers will not be able to understand how the model came out with a particular decision. And this is where we need to have the governance should be here, the what I call HITL, or sometimes we call say MITL, man in the loop or a human in the loop. This can be one of the ways. But again, everything is a remedial measure only. You cannot have 100% issues or risk that can be eliminated. So we are talking about a mitigation effort to the acceptable level. So what is hallucination? So simple words, hallucination is something the output from a machine is not grounded in the reality. For example, you're asking a suggestion to the AI model or a Gen AI, asking for a good place where you can get dosa in Muscat, and assume that it gives you a place somewhere near Sohar. That is called hallucination. Because if you're asking for something near Muscat, or it gives you a place so that you can go to Ruby High Street, from there you go take this turn and end of the place where you will find a restaurant. You find there, you don't even have a restaurant, maybe the automobile shop may be there. And that is hallucination. Why it happened? As I told you, because the data, it remembers the training data too well that it tries to fit into that answer whatever you got. Otherwise, if it doesn't get it, what happens? It creates its own. There are multiple cases there actually out there in the when it talks about hallucinations. So Atmaram is saying that recently Government of India has released a national policy report on the AI governance framework. And Atmaram, you're right. Many such governments, even White House has released something, even Singapore has released something, China has released something. All of them are guidelines. None of them are, other than European Union AI Act, none of them are binding. None of them are regulation. None of them need to be followed. They are just giving guidelines to you. That's it. So what is a hallucination? Hallucination are a model fabrication. The model fabricates an output that are not based on the reality or the input data. It is saying something that cannot be existing. So they can be factual inaccuracies or a nonsensical statement or invented information or even contradictions. In fact, in the year 2022, when the Google was introducing BARD, that AI thing, and in the real launch program, it was given an input asking that when was the first exoplanet was, I mean, what was the achievement of the Hubble, James Webb telescope? And you know what the model said? The BARD model said, the James Webb telescope is the first one to discover an exoplanet in the astronomy. And the James Webb telescope was launched somewhere in 2017 or 18, but the first exoplanet was discovered by somebody else in the year 2006 itself. That is a major goof up by the model. And because of what happened? I mean, the next day the Google stock went down by around $100 billion, but it recovered. I'm just giving an example. And another funny example is that our lawyer in the New York court, in the sense of New York area, based on a case law which he is going to defend in the court, he wanted to have some kind of argument which are prepared by AI, so that He gave a particular situation to the AI, and the AI churned out with outputs, giving a lot of arguments based on certain decided case laws. That guy very confidently took the cases to the judge and he argued based on that. And he has to give citations, so he gave the citations. And the judge tried to verify that he never found anything. None of the case laws like that ever existed in the world. And when asked about it, then he later said, yes, he used the ChatGPT, the generative AI. Then he was reprimanded. I mean, that is the issue because he argued on something that never existed. So these things are things that can happen, hallucination. I mean, harmless things can happen, but again, I just assume that like you are trying to drive a particular location, suddenly you are going to a cliff and suddenly in a hill, and you are trying to take a turn, suddenly as per the route map, and nothing exists there, you may fall down. So major problems can happen. So why do the hallucination happen? Mainly insufficient training data. That is, the data is incomplete. So what actually happened? The model tried to create what they call synthetic data, and it inverts its own data, puts it, and from that data it gathers, and that is a hallucination happen. Incomplete data, biased data, and poor generalization. So you're just giving a statement it cannot understand, so it makes it upon its own, and memorizing too many things and overfitting. That is exactly what we're talking about. And lack of grounding. The model doesn't go back and check for the fact. For example, in the New York case which I'm talking about, the model could have very well gone back and checked whether that particular case existed or not. But that can be, I mean, that obtained from multiple sources, but it did not check it. So lack of grounding and limited understanding. It doesn't understand the problem then, and inability to distinguish the truth because it's an AI. It is not a human being. So just give something, believing it is right. It doesn't understand, distinguish actually. It is very, very difficult to control. And why one of the major reason for the hallucination, they're very, very complex algorithms. Even sometimes the model developers themselves don't fathom it out. And the complex models. So next we are going to talk about auditing. So we now come to the next stage, which is how do we audit AI? There are two things we are going to talk about. How do we audit AI and how do we use AI in auditing? So both the things, because AI is a very, very interesting and what you can say disruptive technology. So apart from auditing, how can the auditors leverage the AI for their day-to-day task? So first, the framework. So right now, what are all coming up? NIST's Artificial Intelligence Risk Management Framework. This is also a framework. It is just came about. It is not mandatory in many locations, which is a comprehensive framework for managing the AI risk and promoting the trustworthiness. It is also like your normal risk management framework. It also has its own 4 stages. Initially identify, assess, then treat, then respond. Then ISO ISA 42001, which is now available in the market. I mean, certifications are available now. Then this is what we call about the OECD AI principles. The most of the organizations, if you talk about, I mean, the AI, the jurisdictions, regulations, or standards is mainly grounded on the what we call the OCR, or the Organization of Economic Cooperation Development. They are a very, very potent international body where a lot of members countries are there. India is an observer; they are not a member country, and the decision on them are binding on the member countries. But this is a guideline only. To understand the guideline, I'll just go here. This is the guideline, the core principles of AI governance. The first and foremost, any AI developed in the world should be for the growth of the human being. Focuses on equitable economic development and environmental sustainability. When it comes to environmental sustainability, another important question to you. When you ask a question in Google, or the same question you ask in ChatGPT, what is the energy difference? Can anyone tell me? You can type in your answer in the chat. So what is the energy difference? That is how much energy is spent by the machines when one particular query is raised in Google, and how much is energy spent when you ask the same in ChatGPT. I mean, Gen AI. I'm not using ChatGPT. Any Gen AI. Can anyone tell me? Okay. Answer is 8 times more. That is, the Gen AI consumes 8 times more processing power than it is required actually for the answer to be given in Google. Just imagine that over a period of time, the entire world is adopting AI, and every day, single day, billions of commands are being issued, or the queries or prompts are being given to the Gen AI models. and just amount of processing, how much energy is being utilized. I won't say the word wasted, utilized. Is it really good for the environment? Are we able to sustain that? How long will it be sustaining? If it is coming from renewable energy sources, fine. Right now, we are using fossil fuels, coal, going to have a major impact on your environment. Then human-centered values. So the AI should respect the human sentiments and value for the humans. That is second requirement from your OECD AI ethics and principles. Transparency and explainability, we already covered that. That is, AI models should be able to be transparent, that is, able to explain the output, and also the output should be understandable by the common user. Robustness, security, and safety. This ensures that AI systems are reliable and secure against the threats. And finally, accountability. This supports that AI actors responsible for their actions and outcomes. That is the entire the chain, the develop the algorithm developer and the overall AI developers, the organization, the implementer, the aggregator, and the launch, the people who use it. Everybody will be accountable. That's a very funny thing, actually, if you look at. So just coming back to the same area where we left. Then, apart from that, European Union AI Act, this is the only binding regulation right now in the world. Then ISACA AI is an auditing framework that we are going to cover next slide. I mean, next few slides later. Then COSO, the Committee of Sponsoring Organization ERM framework, also have a separate session for AI. And IEEE EID guidelines also, ethical design and guidelines on the acceptable use of AI. And World Economic Forum AI governance, this is just evolving. And G7 also coming out with that. Singapore is coming out with a model. And UK algorithmic transparency under your ICO, Information Commissioner Office, is so evolving. But so far, they have been just what you can shadowing the European Union AI Act. But I don't know whether they are going to come with a separate one in the near future or not. So NIST talks about the four things: govern, map, measure, and manage. The same thing, any other risk management framework, yeah, from your NIST, the same model they also follow, but this is AI centric. Next is that European regulations, like the same thing. China, they don't have a specific regulation on AI, but they have a different kind of, I think, personal privacy, etc. That has a indirect impact on your this thing. China, we all know, highly restricted country. European Union, we all know about it. European Union AI Act. Canada, they're developing AI regulation under the what they call Bill C-27. Singapore, right now they have a guidelines, they have an advisory, but in the near future they are going to come with a regulation. UK, as I told you, employee sector-based oversight with the flexible principles, but also they are directly come under the control of Information Commissioner's Office (ICO). United States, there is a guideline from White House, and some like NIST frameworks are there, but operationally, the state-wise, their regulations yet to emerge. OECD, that is what we talked about. UNESCO also talk about primarily based on the OECD. G7 is also promoting, and most of them are innovation focused with the main emphasis on the OECD guidelines. That is what the idea in the future of the regulatory framework when it comes to the AI. So again, when it comes to European Union AI Act, actually the European Union have categorized the AI into four categories. Number one is that prohibited. That is unacceptable risk. There's nothing but unacceptable risk, then high risk. The categories are something: unacceptable risk, then high risk, then limited risk, and minimal risk. These are the four categorization. So unacceptable risk means any AI which comes under this category will not be allowed to operate inside the European Economic Area. Simple. You cannot bring it in at all. No second thoughts about it. Like a social scoring, any particular, like a, what you can say, facial recognition system, unless the facial recognition system is used to identify a missing person or a safeguarding a person, then it can be used. Otherwise, for any understanding the person and try to or create harm for an individual. Like, for example, you're having a system in your recently concluded there's a protest happened in London. I mean, then there's a assume that there's a AI used to profile the faces of each and every individual who participated in it and try to create some problem for them. Those kind of things will not be allowed. That is the unacceptable risk. Then next is called the high risk category, like that medical devices and those kind of a thing comes under this particular thing, wherein they are okay with the proper oversight. They can be allowed to be operated inside the European Economic Area, but with a very strict oversight. First and foremost, if at all any devices or any AI to be brought in, they have to be first disclosed to the commission. That is, there's a register, and the authority should be they have to register it, wherein the multiple requirements are there. Like for example, the algorithm, the basics of the algorithm should be given. The model code should be given, output should be given, accountable person should be given. Based on that, registration be published. After that, after a certain period, it will be allowed to be operated in the environment with very, very strict controls. But you can do that. High risk, then limited risk, and medium risk, as a minimal risk, you can use it. Like for example, guys, games and all those things, there comes under your limited risk, and the chatbots and all those things comes under your minimal risk. So usually they don't have any controls over it. They have a very limited control. They don't have a controls at all. I mean, you can use it without any problems. So when I talk about AI auditing, so AI auditing is nothing but, I mean, it's emerging as the professional discipline to address the need. Right now, the need is extremely high, serving as a vital mechanism for the ensuring the trustworthiness, accountability, and the compliance across the AI lifecycle. The most important thing is about the trustworthiness and also the accountability. And compliance will happen only when you're having the legal or a regulatory framework involves in the market. Okay, fine. But still, these two need to be established. The most important element is the trustworthiness. Can we trust an AI? This is a question that everybody should ask, especially IT auditors like you and me. Because if you cannot trust the output of a particular model, then what happens is that the model fails. And unlike your IT system where some investments are made, but compared to AI, I mean IT, AI investments are extremely high. Just imagine that you developed a model and implemented it and later found the bias in that. You have to immediately stop it, take it out of the production, and you need to correct it, and you have to put it back. You need to do training, retrain also. Unlike your IT system, where when it's in the production, there's a bug is identified where the programmer can intervene and do some what you can say some fixes and rerun it. Doesn't happen that way in your AI. You need to train them a lot. Again, it's going to take equally longer time. Cost is very, very high. So you cannot no, afford to make mistake. So trustworthiness is extremely important. Accountability. Again, by each and every area, the developers, the implementers, the integrators, the operators, intermediaries, everybody should be made accountable. So to ensure that all of them are properly done, we as IT auditors or AI auditors should gear up ourselves. So AI principles range from rules to social impact, like they're rules-based, lawfulness, the ethical alignment. I mean, all of them are the principles that we need as an auditor, we need to ensure. Fairness, that is about all of them we already spoken. We are coming in a different manner over here. That's it. Same thing also we did talk about, so we are not going to go deeper into that again. The inherent opacity of the complex AI system, because even sometimes what happens is that the developers or the algorithm developers themselves do not understand how a particular output came about from a particular model. That is what we call the black box problem. And that poses a significant challenge to accountability and trust. Say accountability is one angle. I definitely is important, but trust is the most important thing. Because if a human being cannot trust a machine, then what? The machine has to be abandoned. So to address this, two critical concepts have emerged: transparency and explainability. This is part of that, yeah, what we call the ethical framework from the OECD. So that means if you have these two, then you can say that the AI is trustworthy. That is, you can trust the AI. So that means as an auditor, you should be involved in the complete AI life cycle. So the AI life cycle is not like a traditional SDLC. It somewhat mirrors that, but also has additional issues, I mean, additional requirements in it. First and foremost, the problem identification. See, the question is that in a normal IT development, for example, if an organization developing an ERP application or any specific CRM application or any accounting or payroll, there's a very clear business case will be there. And the requirements are very crystal clear developed. Either agile methodology or waterfall, doesn't matter. The requirements are gathered and development happens. So that means you have the problems very clear. The solutions are also can be given by the machine. Then you can also do a cost benefit math. Then based on the return on investment, you are going to allow the program or the application to download. Then you are going to implement it. It is as simple as it is. But in the case of AI, it is not something that you are going to just develop and implement it. You need to understand what kind of a problem that you're having that cannot be addressed by traditional IT system for which you need an AI system. So most of the problems happens at this stage. People are not clear what AI can do or what AI cannot do to you. That is why you should be able to come in as an auditor, advise the management about what kind of issues that cannot be solved by traditional IT system because AI is going to be extremely expensive. It's also expensive to maintain and monitor. Unlike your traditional IT system, once it is implemented, and once it's a user acceptance testing and the other testings are validated, unless the model changes or the IT system changes very significantly, it is predominantly doing the same thing over and over again. Not the same with AI because we never know what kind of a data it encounters and what kind of a model or the output it is going to throw. So that is going to be a major challenge here. So understand the use case. Is it really required? Recognize the challenge that IT can address and most importantly, the challenges that AI cannot address. Once you are very clear, okay, I'm very happy that there is a clarity or the business case is there that I got a problem that can be addressed only by AI. The next question is that how am I going to address this? I need data. Where do you get the data? Okay, internally generated data, very good, available. Next is ensure the data is complete clean. That is, you're formatting the data, you ensure the missing fields are taken care. But is it enough? May not be. So you need to go out and buy the data. When you buy the data, licensing issues, data poisoning of the data, and at the same time, inconsistency of the data, sensitivity of the data, all issues, the data governance comes into picture that you can add value. You can clearly have a framework very clearly done so that by the time the models are developed, the auditors and the data stewards can work with the developers, modelers to ensure that the right data goes inside. So that is nothing but you are taking out a very, very important thing, GI, that you are taking out. You are ensuring that the garbage doesn't go in. Then model development. So when you talk about the model, algorithm, there are multiple algorithms are there, and what we call the multiple hyper parameters are there. So there are multiple things are there. Which one you are going to select for what purposes? For example, if I'm going to understand an attribute of a person based on the appearance, then I'm going to look at the height, weight, and also the height, and that is then look at other things. I don't want to take a weight of the person. So everything is a hyperparameter. The more hyperparameter, the more complex it is. The lesser it is, overgeneralization. So you need to look at the app parameters and model adjusting, model tuning, model training, model validation. All of them will require lots and lots of governance from the auditors. Then evaluating the model. Accuracy. Usually, whenever model is developed, you have 100%, you have a data, what we call the 100%. Whatever data you have is 100%. Out of the 70% is generally used for training, and 15% is used for validation, and 15% is again used for testing. This is a thumb rule. Whether that is done or not, because based on that only you can actually evaluate the accuracy. But this is about the data that you know you have and you use the train on it. But what about the data that the model will get? Because when it is implemented in the real world, it is going to encounter the data. Is there any way by which we ensure that the data doesn't get in that can corrupt the model? So that is again data filtering. So that is again data governance. And deployment, integrate into real world. And again, until the model is completely stabilized, there's nothing called stabilization over there because it keeps on learning. Every output from the model has to be weighted by a human being. That is what we call the HITL, human in the loop. The auditor should ensure that whether the human in the loop is properly followed or not by 100% base. No exception should ever be given. So this way, over a period of time, we can ensure that the model transparency and the trust, then accountability, that is the trustworthiness can be developed. And that is the line monitoring maintenance. That is, at the end of the day, the model is behaving the way you want it and ensuring that in case there is a deviation which is not acceptable, there has a process by which the model is immediately stopped and reversed and again the human comes into the picture and corrects the situation. So all of them are entirely different coming to depending, I mean, considering your regular SDLC audits. So audit has a major role to play. We cannot do an audit on the algorithm. We are not capable of it, but we can audit around it to ensure that the garbage doesn't go out, go in, at the same time the monitoring happens on a regular basis. So it starts from design and development, goes on to testing and training, then deployment, monitoring, maintenance, and decommissioning. Decommissioning is also very important because at the end of the audit life cycle or the AI life cycle, whether the data or the model, how the discontinuation happen, whether the parameters are disabled, where the data stores, data retention policy, traditional daily data retention policy the decommissioning policy will come into picture here also. Next is what are the consideration we can have? Data governance we talked about. Ensure that training data is high quality, unbiased, and adheres to the privacy regulations. And algorithmic fairness and bias. So systematically test the model's output, but this is only during the operational stage we can do. Across the different demographic groups to prevent the discriminatory outcome. This is very, very important. And explainability and transparency, that is how the black box problem can be solved. That is, any black box models, the output how can be addressed and identified, and if the explanation can be given. Robustness and security, we already discussed about it. Evaluate the model's resilience against adversarial attack, which you saw in one of the slides earlier. There are multiple methods by which it can be stopped, it can be mitigated. I'm not discussing here, but I'm just giving an example. So first and foremost, when I talk about AI governance, first have a framework for the AI oversight and accountability. You need to have like a AI governance committee, maybe part of your security steering committee, or maybe part of AI governance committee where you can also have a DPO as a member in that. Then privacy risk management, which will automatically, if you're having a DPO, that will also taken care here. Data classification, you can leverage the existing organization data classification policies. Collection, use, and disclosure, you can also have a privacy and other things, other requirement. Also, maybe having specific for AI also. This is somewhere very, very important because many organizations, what they don't have a restrictions on people using AI in their workplaces. So, for example, there is one case somewhere in 2023 that in Samsung, they used the chat GPT to they typed in the minutes of the meeting that concluded in the board meeting, the top level board meeting for the purpose of generating the meeting minutes. And that contained very, very sensitive information regarding the future plans of Samsung. That also became public. So that means the most important element is that the people, the employees should be taught on the fair and acceptable use of AI because without knowing the perils or the problems of using the chat GPT, if any sensitive information goes out, we are going to have a major issue there. Data licensing, that is when you buy the data for the training purposes, you need to understand the usage requirements, any restriction, licensing clauses and condition, where it is used, whether the licensor themselves have the rights over the data. Otherwise, you'll have issues. Data ownership. Again, the bought data, you might not be the owner, you might have the right to use, but you might not be the owner. And restrictions when you're licensing and all, what are the licensing terms? We need to look at that very clearly. Ethics and legal compliance. Ensure data use aligns with the enterprise standards and laws, ethics laws. Data cleansing. Once again, removing errors and inconsistencies from the data, that is again part of your initially data governance will come. Then testing and validation, verifying the accuracy and refining the AI model. These are the areas where audits can actually add a lot of value into the AI overall activity. So the AI not only makes the organization better, but also can make the life of an audit easy. So usually when you talk about AI, sorry, any audit, it is all about verifying the controls. The controls are present. I mean, there's always a good evaluating a criteria. You have a criteria, you have a condition. This is what we call the to be. This should to be, but this is as is. Like always the audit is nothing but verifying what it is now, compare with the to be and see if there's a deviation, then make recommendations on it. This can be done by AI, robotic process automation. So automated transaction analysis. AI can scan thousands of transactions to detect anomalies, duplicates, or unusual patterns that might indicate a fraud or errors, where an auditor might not be able to manually do that, or rather it may be time consuming, which can be done by AI in a very short period of a time. Trend analysis. Machine learning algorithms can identify the trends, patterns, correlations. Nowadays, they are used also in many banks for the AML purposes or maybe fraud detection or fraud prevention, etc. Predictive analysis like a customer churn rates or maybe predicting some potential risk before that can happen, even preventive maintenance, all of them can be done using a predictive analysis. So the AI can also be used for your auditing your risk assessment purposes like anomaly detection. So the AI can actually flag suspicious activities in real time using the historical data. Like if right now you're having a SOAR tools, that is a security orchestration automation and response. Then your SIEM tools, security event information event management tools. Most of them incorporate some way of AI enable so that in the real time they can actually provide you with the input of a suspicious activity. Even IDS also to certain extent also need to, I mean, will have also AI capability like a neural network ideas, etc. And continuous monitoring. So AI can provide that ongoing surveillance of our transactions, ensuring their comprehensive coverage and reducing the reliance on a periodic checks, etc. And fraud prediction, using your models, you can predict whether a particular transaction can happen or a particular fraud can happen. Like a train AI models to detect potential fraud schemes by learning from the past data, etc. Then automate is a routine task, what we usually call the robotic process automation. Data extraction. So AI can extract data from multiple formats like a PDF, scanned documents, or emails, and reducing the manual effort. Reconciliations can be done. Automatically match the invoices, receipts, and accounts to identify discrepancies. Very, very good for the financial auditors. Lots of field work can be done by the AI or robotic process automation. Report generation. Using the LLMs, you can ensure that like a proper reports can be generated. So auditors writing the report, that particular paid can also get reduced. Then enhancing the decision making. So NLPs can AI can analyze the contracts, agreements, and policies to identify the compliance risk. And they can also do a scenario analysis. They can simulate what if scenarios to test the internal control under the different conditions. And they can also rank the risk prioritization based on the predictive insights and helping the auditors to focus on the high risk areas. So there are multiple such benefits that can be done, I mean, by adopting the AI in the audit field actually. So continuous auditing. So usually if you look at auditing is a kind of a point in time activity where an auditor goes at a particular point in time, covers a particular transaction on a particular period, then actually test the control and come with the recommendations. But that is going to be always a post-mortem activity where problems are identified maybe very, very late. So in the case of a continuous auditing, so what they can do, the AI can do a real-time auditing. Instead of periodic audits, AI enables a continuous review of the transaction, wherein you can set up the audit hooks or the maybe computer-illustrated auditing techniques, etc. And they can also provide early warning system like lead indicators. They alert for the unusual patterns or deviations in the process, etc. So that actually by doing the real-time monitoring and again proper early warning, a fraud or any errors or any major issues that are going to happen might also be identified far quicker and prevented. So what are the various tools available? Machine learning like anomaly detection and predictive risk scoring using the machine learning models. Then automating the repetitive audit tasks as a data entry by robotic process automation. Then reviewing the contracts and unstructured data using the NLP tools. And also visualization tools like displaying trends, anomalies, and patterns in a dashboard using the visualizations, etc. So what are the advantages and the disadvantages of using the AI in auditing? Faster audit cycles, advantages, reduce errors because again, by the logic, the human machine makes lesser errors. Fraud detections can be faster. Enhanced insight into the various analytics can be done in the real time. But one of the major issues associated with AI, they are high costs. And second, during the high cost, at the same time, even if an auditor has to implement an AI model, then again, the algorithm should be bought from somebody. Even if the developer is allowing you to have the algorithmic access, you will not understand as an auditor how the decisions are made. So trustworthiness is an issue. Again, the data that you're going to use for training, whether the data is sensitive because you're going to use the client data, then whether the data is accurate, is it reliable? So that the same data questions will also comes over here. And apart from that, the traditional auditors need to be trained in using the model. So that is going to have a additional cost and also resistance to change. That's a common human problem That always happens. So next we are going to talk about the AAIA. So this particular certification was launched by ISACA on 19th of May 2025. The beta examination was actually done in the month of April. In fact, I took the exam on 28th April. I got my results on 18th June only. I got certified by end of June actually. So what is the idea? It is the first advanced audit specified AI certification designed for the experienced auditors. So you need a prerequisite. If at all you people want to take up AI certification, you need to have one of these, either a CISA or a CIA or a CPA, ACCA, etc. Some more the certification are going to get added, what I believe. But right now, these are the list of things. I'm sure all of you might be CISA, so we can take it up. So it aims to equip the professionals with the skills to assess and govern the AI system, audit, addressing the risk, then identifying the opportunities and ensuring the compliance with the safeguarding the organization integrity. So right now it's available. I mean, you need to have this or CPA, CI, etc. to even be eligible to take up the examination. So there are three domains. That is, one second. Okay, so we have the first domain, that is AI governance. It is around 33% weightage, not 30, 33. And operations, this is the biggest area. I think is around, if I'm not wrong, it's around 43. And I think the remaining 24% comes over here, or it is 46 or 21. If I'll come to that again. No issues. 21%. Auditing tools and techniques is the one, uh, third domain. Totally, you are going to get 90 questions. We are going to talk about talk about the next slide. So, what are the exam content? The governors, the domains and their contents are given here. Operations and the requirements, governance and program management, AI risk management, specific to AI. Then privacy and data, where we are cover the program like how the European Union AI Act and GDPR and also many other privacy regulations across the world have an impact on it. Leading practices, ethics, regulations, and standards for AI, etc. are covered there. Operations are the biggest area. And when we talk about data management, all of them are specific to AI. Data management, we are not talking about the normal organization data governance, but when it is coming to specific to AI, AI solution development methodologies and life cycle. The life cycle are what I showed you. Change management specific to AI, supervision of AI solutions, testing techniques for AI solutions. This is very important. As I told you, we have to have a 70, 15, 15 rule. Then threats and vulnerabilities specific to AI, incident response management to specific to AI. These are very important. Incident response is very important because any AI incidents are going to have a far-reaching consequences than your traditional incidents. Auditing, audit planning and design, audit testing, sampling methodologies, the same thing what we usually cover in the normal CISA auditing, with some emphasis on AI audit outputs and also some data analytics, etc. So examination is 90 questions, 2.5 hours time limit. At that time, when we were appearing for the exam as a beta, it was only available as a remote version. Nowadays, it is available, I believe, in the PSA exam centers also. So you have a 2.5 hours time and the same 450 criteria. So you need to get 450 or above. So the grading is 800. So exactly same thing, 800, 200, 800. You need to get 450 or above to pass the examination. Again, the one very important thing is that for certification, you don't need to actually have what we can say any experiences. So once you pass the exam, you have to pay that $50 application fee. That's it, and there's no other experience. Like in the case of a CISA, we need to show that 5 domains experience with first and second domain having at least some weightage. Like that, you have that requirement, right? Those things are not there. Being an active CISA or having any of the certifications is enough, whatever we listed there. And once you pass it, once you apply for the certification, you'll automatically get certified. The CPA requires 10 hours. 10 hours is a CPA requirement for the AIA examinations. Now, the another important element for all of you is that why do we go for the AIS certification. What is it in for us in the future? I need to tell you that how CISA transformed my life when I appeared. I mean, I took the CSI exam in the year 2000, I passed. Yes, 1996, I became a chartered accountant, and in the year 2000, I passed my CISA. After that, in fact, I was also a programmer. I got job opportunities to get into complete into programming. In fact, I also had job opportunities from United US and all at the same time. I didn't take it up, but I became to the auditing field, and I was thrust into IT audit. And from there, I also took up my CISS certification, never looked back. Most of the time, I was in the IT audit only. So it's actually the same kind of a momentum or the what we can say the kind of a dawn we are seeing that for your auditing also. So what I recommend all of you is that consider the AI auditing, AI certification very, very seriously. Okay, so what are the opportunities? So core, what are the requirements for you? Core knowledges and areas of technical skills. So deep understanding of the machine learning algorithms, model architecture, and the AI lifecycle. But please understand, you are not going to get this in a day or two, or in a maybe 2 or 3 months or 6 months. First and foremost, you should know whether you can get hold of a model algorithm even to understand it. It's going to be very difficult. Even when it is developed inside your organization, they get talent gap, understanding. It's going to come slowly. It's not going to, it's not that you're going to learn today and tomorrow you're going to understand the algorithms, etc. It's going to be a painful process. And at least we have the risk management capability. So expertise in risk management methodologies, including the threat modeling and compliance framework, like for example, the NIST, the AI RMF, and COSO AI ERM framework, etc. And data sciences. But this is going to be a bit technical. So proficiency in statistic analysis, bias detection, and fairness assessment, and model interpretability tools. You can use that, but again, you want to understand interpret the results of the model interpreting tools. Also, you need to have some technical knowledge. Regulations. Right now, we are having European Union Act, but GDPR to a certain extent touches not on AI, Europe, not on AI per se, but it very clearly says that any output, any mission output, which is going to have an impact on a human being, has to be always weighted by a human being. They are the ones who come to the human in the loop, man in the loop. So to that extent, GDPR covers that, and of course, ISO 42001 is the currently available. So the job market for AI governance, I'm talking about AI governance. Right now, in the year 2023, it was around $123 billion. Right, and the year 2032, it is going to touch by $2.3 billion. And it is always, I mean, right now the prediction is that like the demand is going to be far, far greater than the supply that you can get. So if you are going to jump into AI auditing right away, you are going to have a very, very bright future ahead of you. You may be the trailblazer rather than the following the trail. So multiple such things are appearing. So I'm not going to go deeper into each and everything. These are just statistics I put from some research. So what is the career path that you can have? Like for example, certification and training, obtain relevant certifications and specialist AI, like AIA. Another certificate from IAPP is AIGP, Automation Governance Professionals, from ISACA AIA. And another thing has come up for security management called AAISM. And advanced competencies like AI risk data auditing and foundation skills like general AI able basics, etc. You can get a lot of courses like this in Udemy and all. You can do that. Even YouTube has lots of videos. YouTube is a very important media. You can get a lot of initial information from that. Then anticipate career opportunities, explore diverse roles in various industries and organizations, specifically when it comes to the protect industry like a healthcare industry, banking industry, financial industry, public industries. All of them are highly regulated, so you might be required there. Anticipate increased demand and leadership roles in the AI assurance. So over a period of time, what happens? You can get into the leadership and governance roles, like the board member or a director in charge of the AI governance, etc. So what kind of a foundations you might require? Like for example, CSAR, comprehensive understanding IT audit, another thing. Data governance, like a CRISC or a CISM examples. AI and ML fundamentals, you can do a lot of courses in Udemy, or many universities are offering those courses also. So what are the advanced competencies? We already covered AI and ML fundamentals, data modeling, auditing, tools and techniques, cyber security. These are the things. So certification like ISACA AIA and IAPPC IGP, then foundational certificate like a CISA, CRM, CRISC, then ISO 42K for standards, and we already covered these things. Then what are the path we can have? You can start from AI auditor, then go to the compliance and risk rules with banks, healthcare, government, and tech rules because these are called restricted or regulated industries. Then advisory consulting, you can provide the expert advice to organizations on AI governance and ethics, and you can also get roles in Big Four consulting. In fact, what I come to know is from my sources, the Big Four, they are going heavily into AI nowadays and AI governance in ethics, participant boards and committees to shape the AI ethics and governance, etc. So the path is very, very, very good, ladies and gentlemen. And I believe that all of you should get into AI, and it's a very potent field. And as I said, right now I'm seeing the cusp of a dawn of a new era, wherein in next 5 to 10 years, even you can say even lesser than that, the demand for AI auditing and governance is going to be extremely high. So you should be the first one to get into that, and you can have a very high, very accelerated growth path in that area. This is a time for questions, friends. Okay, I can see a comment from Russia asking for, can we get the slides? Definitely, I can pass it on to the chapter, and the chapter will take a decision to give it. But I don't have any issues on.
Thank you, Mr. Shani.
Okay, friends, do you have any questions? I can answer them.
There is a question now. When you say AI auditing and governance is going to be in high demand,
Okay, then how will the risk management come into play? Because governance, and again, when we talk about auditing, it's all about risk-based auditing, right? So understanding the risk, the governance, the main outcome, if you look at the corporate governance, it is nothing but strategic planning or strategic alignment, risk management, and assurance process integration. So without understanding the risk, what specific risk AI poses to your organization, without you cannot even do the governance at all, like a data governance and understanding the AI ethics and other requirements, regulatory compliance, all of them comes under the umbrella of a risk management. So risk management and governance goes hand in hand together, even when you talk about the AI.
there is another question. Can you shed some light on AI, AMS, and related ISO?
What is AIMS? ISO, to be honest, I've never even touched it. I don't even have a copy of the 42 one, but people told me it's very good. So what is AMS? AI, Mustafa, you can, if you can elaborate on it, I'll be able to help you on. Management system, AI management systems. AI management systems, right now, they are not there because AI is not an IT system where you can manage. They are what you can say, league on their own. They decide on their own. It is more into governance rather than the management system. Right now, I have not come across any such things. Any other questions, friends?
What are the AI tools generally used for auditing?
Yeah,
Like
so
I can.
mainly it is like again tools. If you specifically ask for, let us be like models. You might have to look at the industry whether something available. Mainly, what we talk about the NLP, natural language processing. I mean, assume that you have a 1,000-page contract. You can just OCR it and just allow the model to go through. It will give you the output based on the prompts given, like all the give number of repeated words like that, whether this is completed or not. You can also tell the model look for this compliance, and it will give you. So NLP is one thing. Then what we can say predictive analysis. Like by financial auditors, they can you can show the AR, AP or the financial transaction to predict something or not happening, having something. That is predictive analysis and error prevention, fraud identification, etc. Then robotic process automation. You can automate the tools like checking, the quality, the data reconciliations, etc. Multiple such tools are available. This again is still evolving. Right now, what AI can do is imagination only. You can just imagine it can do anything. But only thing is that you should know where to use it. Right now, the costs are very high because the AI, the GPUs are extremely expensive. So the question is that, I mean, as I gave the example, to bring a laptop to your home, why you, I mean, go to up, I mean, hire a 50-ton or a 20-ton truck? Because AI is a 20-ton truck. And your problem may be like a laptop. Why should I carry unnecessarily that? So do we have a problem? So even the most important element of the AI auditing or the tools is also expensive. Even AI auditing tools also expensive. So right now, it is the limited way it is getting into the audit. I mean, the same thing happened in the cloud in the earlier days because cloud was not there because not because the cloud concept was not there, it was there, but the availability of the machines and again the virtualization made it happen. Similarly, breakthroughs will happen. Maybe next 5 to 10 years or maybe 15 years down the line, we may see that we may get the AI being more affordable with more and more things coming up.
Thank you. We are coming to an end to this session. I think it was such a packed, insightful session today. Thank you all for your active participation and a good round of applause for our speaker. I would like to invite our Director CISA certification, Mr. Hassan Ahmad, to give a formal vote of thanks. Over to you, Mr. Hassan.
Thank you so much, Mr. Arul. Assalamu alaikum and good evening, everyone. It's my pleasure to have a vote of thanks today's session. First of all, I would like to thank His Majesty Sultan Haitham bin Tariq for providing us growth as a chapter in Oman. I would like to thank CBFS for supporting us as a functioning in Oman. I would like to thank our esteemed speaker, Mr. Srinivasan. The way he explained the hot and complex topic in very simple way with the various examples. Sir, the way you share your insights, experiences, stories related to governance issues in AI lifecycle, etc., was very fantastic. I would like to thank our all board members, organizers for tireless support to make it happen. Last but not the least, I would like to thank our audience, our members, who are the reason for our chapter's existence, without whom we can't function. Thank you very much, everyone, for being a great support for us. Thank you so much once again, and over to you, Mr. Arul.
Thank you, Mr. Hassan. Uh, that's a fantastic session today. And I just wanted to have one more round of permission from our speaker of the day, Mr. Srinivas, to share the presentation slides and the session video to our members. Do we have your consent,
Definitely,
Mr.
sir.
Srinivas? Thank you.
100%.
Thank
So I
you
will,
very much.
in fact, I will forward it to you people, and yes, you can freely use it. No restriction, nothing. I mean, I'll be happy. The more people reach us, more awareness happens. I'll be really happy.
Thank you,
You
sir.
can
Thank you
freely
very
use it.
much. That's so awesome to hear that actually. Like, and this was a like fully packed session as of today, and it is actually fully packed, insightful session, and that was so fantastic. It was a fully engaged session as well from all the members, right from the beginning to the end, and that was a fantastic session for you and for our members. Thank you, sir, and huge thank you to everyone for joining us tonight. And we will look forward to seeing you at the next chapter event in coming soon. We will be sharing the details soon. Thank you everyone, and have a good day.
Thank you, all of you, and thanks for patiently sitting and listening to all my the explanations and all my words or whatever I spoke about. And any what you can say queries on IA examinations and other thing, you can direct to me. I will be very really happy to talk about that. I won't say it's a very easy exam. At the same time, I won't say it's a very tough exam. But yes, you can do that, and definitely it will add a lot of value to you. Thank you, all of you. Good night.
Thank you, sir. Thank you, board members. Thank you, Vice President. Thank you, Ajit, our past president. Thank you, chapter members. Thank you, guests. We'll be winding up this session by now, and we'll be sharing the presentation and the slides through our chapter portal and also to our members through email. Thank you.
Thank you.